Hello everyone, welcome to DC Minds. In this video, we are going to learn about a use case of R value reference. In previous video, we saw what is R value reference. Now let's see its use case. So here we have a situation where we have a vector and it has 200 elements and we want to multiply each element by 3 and store into another vector. So for that you can write a code like this. So this code will create a vector and add 200 element to that vector, and this is a function that will take this vector and create a new vector of same size as this vector, and then it multiplies that vector element by 3 and add into this newly created vector. Okay, so when you write a statement like this, in this case what will happen, this triple function will be passed this vector. So when it will come over here, it will create a new vector and whose size is same as this past vector, that is nothing but 200 elements. And now with the help of this range based for loop and auto keyword, we will iterate over this vector elements, and then each element we are multiplying by 3 and adding into this newly created vector. So if you don't know the concept of range based for loop and auto keyword, you can watch my video on this concept, and the description in the description below the link is given for this concept. Okay, so what will happen, it will iterate over this vector that has been passed, and each item is multiplied by 3 and added into this newly created vector, and now it is been returned. So when it is returning and the value is getting assigned, there will be two copy of vector that will be created. One will be temporary object that has to be returned, and second is when the assignment operator will happen, means basically when the vector that is been written is assigned to this vector. Okay, so in this case there will be two operations. The first can be avoided by the compiler with the help of return value optimization, but when this second copies happen, that is when assignment operation happens, at that time what will happen, a separate means memory allocation will happen, will be created for 200 elements, and it will copy each of them one by one. So here we have lot of memory allocation is happening and copy of that element is happening, so that is redundant. So this can be avoided in C++3 itself by making this triple function to return the vector by pointer. Instead of creating the vector by value, what you can do, you can just create this vector as a pointer and return that. But whenever you create a pointer, at that time also for that pointer some memory will be allocated, that at least one memory will be allocated. And main goal of C++ is to avoid memory allocation. So returning a pointer vector is not a good solution. So another solution could be is you can use a const reference variable. So in this case what will happen, there will be no extra memory allocation and no extra copy. So this vector will directly point to the vector that has been returned. So there will be no copying over here. But so what if you want to use this vector that has been returned and you want to modify in later part of the program? So in this case you cannot modify because you are storing in a constant reference vector, so you cannot modify. But we want to modify this vector later and we want to avoid the copying and allocation of extra memory. For that purpose you can use R value reference. So when you use R value reference, what will happen, it will avoid the extra memory allocation and copying of the elements of each vector one by one, and later you can, whenever you want, you can modify that vector. But whereas in this case you cannot modify this vector in later point in time. So this is one of the use case of R value reference. Okay, it avoids extra memory allocation and copy of that location memory, that is elements of the vector in this case. Let's see another use case. This is, in this case, what we are trying to do is we are trying to concatenate multiple string. So what will happen when it will perform this h plus e, for each plus operation one temporary storage will be allocated. That means for HE, one memory will be allocated temporary, and then again HE plus LL, another temporary storage, then again HELL plus O, another memory. So for each operation there is a extra temporary object that is been created and returned, that is called R value. So instead of creating a temporary storage and returning, we can make this plus operation to accept this parameter as R value. That is, with the help of R value reference, you can modify this plus operation that will take R value reference and avoid the extra memory creation. So you might say, instead of performing operation on R value, you can directly create multiple L values and perform those operations, something like this. You can create multiple L values and then perform this addition operation. So in this case, you will say, instead of creating a temporary for each plus operation, instead of creating a, a temporary location, you can modify one of this storage and keep on adding. So what if there is a situation, if you want to use this one of this one of this string that you have modified in later point in time, at that time what will happen, instead of getting this he, you will get the entire modified string. So that will be the problem. So with the help of R value reference, you can avoid here extra temporary allocation. Okay, so this is another use case of R value reference, and we in next video we'll see some more R value reference use case. Thanks for watching. If you like this video, please subscribe to the channel and hit the like button. If you have any query, please comment it and watch my next video to understand another use case of R value reference.